Okay, so we're talking about solving exponential equations. So looking at this first one here, we know when both sides are square rooted, we can ignore the square roots. Technically, we're squaring both sides, but really doesn't matter. Whatever's inside the one square root must equal the other, what's inside the other. So 3x minus 6 equals 9. Add 6, divide by 3, and you get x equals 5. Sine of 3x minus 6 equals sine of 9. Well, guess what? 3x minus 6 has to equal 9. So x is going to be 5. Over here, all the denominators are the same, so we can just ignore the denominators. We're going to get x equals 5. The only problem with this, because of these, x cannot be 5, so this would have no solution. Now, we get down here to exponentials. 2 to the 3x minus 6 equals 2 to the 9th. Well, the exponents, since the bases are equal, the exponents have to be equal. So we get 3x minus 6 equals 9. And we get x equals 5. Does it matter if the base is e? It does not. 3x minus 6 equals 9. Add 6 to both sides. Divide by 3. X equals 5. Now, we get to a problem over here. Our bases are not the same. But is there a way to write 4 so that its base is 2? Yes. 4 is 2 squared. Now I can use the property of exponents and multiply this 2 by 3x minus 6. Do our distribution. And get 2 to the 6 minus 12 equals 9, 2 to the 9th. So now I've got the same base. I can just solve 6x minus 12 equals 9. I'm going to add 12 to both sides, which would give me 6x equals 21. Divide by 6, so I'd have 21 over 6, which reduces to 7 over 2. It's a little bit different, but you just need to make the base the same. So that's the idea here. So the first step to solving exponential equations is make the bases equal. So I got 4 here and 16. Well, I can turn 16 into 4 squared. I'm not going to do anything with the left, but the right, I'm going to have to multiply 2 times 2x minus 4 and get 4x minus 8. Then I'm going to set the exponents equal to each other and solve. So 3x minus 2 equals 4x minus 8. A lot of people subtract 4x. I subtract the 3x and add the 8. So I'm going to get x right here equals 6. Doesn't matter which way you do it. You'd end up with negative x equals negative 6 if you subtracted the 4x and added the 2. Then you have to multiply both sides by negative 1. Some refresher, b to the xy is b to the xy. B to the x times y, b to the x times y. B to the negative x is the same thing as 1 over b to the x. And 1 over b to the x, this is the one you'll use way more commonly. 1 over b to the x is b to the negative x. Okay, let's give it a whirl. So 2 to the x plus 5 equals 16. Well, I'm going to turn 16 into a base 2. So it's going to be 2 to the 4th. And so now I'm just solving x plus 5 equals 4. Subtract 5 from both sides, and x is negative 1. Over here, I'm going to have to do it to both of them. This is 3 squared. This is 3 to the 3rd. So now I'm going to have to do my distribution. 2x plus 2, 3x minus 3. Now I've got that. Set the exponents equal to each other. I'm going to subtract 2x and add 3. Get x is 5. Here's the one we're going to want to do our negative exponent. 125 is 5 to the 3rd, but I can't deal with it down there. So I'm going to make 1 over 5 to the 3rd into 5 to the negative 3 power. So now x minus 2 has to equal negative 3. I'm going to add 2 and get negative 1. Okay. Your turn here. Oh, we can see these. Usually if you see 4, 8, 16, 32, or 64, you're going to use base 2. 9, 27, 81, 243 is base 3. 25, 125, 625, base 5. All right, your turn. Pause it here, work these out, and come back and check your answers. Okay, so 243 is 3 to the 5th. So all we have to do is solve 2x minus 4 equals 5. I'm going to add 4 to both sides, divide by 2, and get 9 over 2. Over here, I'm going to have to do it to both of them. 8 is 2 to the third. 32 is 2 to the fifth. So do your distribution. And 2 to the 3x plus 3 equals 2 to the 5x. So 3x plus 3 equals 5x. I'm going to subtract 3x and then divide by 2. So x is 3 over 2. So here's that same thing again, 64. I did it with 2 here. You could have made 64 to the third and done it that way. That'd work out just as well. I did it with both of them. Just keep it like on the last page where it said, if you see 4 and 64, make them base 2. Well, you could have made this base 4. So 2 to the 2x plus 6 equals 2 to the negative 6. So I'm going to subtract 6, get 2x equals negative 12, divide by 2, and x equals negative 6. Okay, so there's how to solve when they have the same base. Now we're going to go and move into the next one and talk about them when they don't have the same base. So all of these have the same base, but what happens when I have something like this? 3 to the x equals 12. Well, what power do you raise 3 to and get 12? There's not one, or not a whole number. So we're going to use what's called a logarithm. So if 3 to the x equals 12, then log base 3 of 12 equals x. I always think about it, these two kind of switch. In Delta Math, in Desmos, what you'll type is log, and then there's the underscore button, and that will drop you down here and let you type the 3, and then you move out and get to 12. Type that in, you'll get around 2.262. What this means is 3 to the 2.262 power is about 12. This number just keeps going on forever, but it does solve that. So if a to the b equals c, then log base a of c equals b. I always think about it, if there's no log, you write log. First number doesn't change, then switch the other two numbers. And vice versa. If you have this, if there is log, you don't write the log, and then you switch the other two numbers. Okay, so let's give it a whirl. This first one, the first thing you're going to do is write log. That number doesn't change. Switch the other two. Okay, you do the next 3. Pause here, work them out, and come back and check your answers. All right, so this would be log base 4 of 2 equals 1/2. Next one would be log base 4 of 64 equals 3. And then log base 125 of 5 equals 1/3. So now we're going the other way. First thing you're going to do down here is get rid of this. You leave the first number and you switch the second two numbers. Now, these should work because this should just make sense. I mean, 8 to the third is not 2. 2 to the 8th is not 3. 2 to the third is 8. Okay, pause here, do the next 3, come back and check your answers. Okay, so 4 to the negative 4 equals 1 over 256. 4 squared equals 16. And 3 to the 6 equals 729. I do really want to get you in your head of understanding what this is asking. This is asking, I want you to try to do this without the calculator. What power do I raise 3 to get 81? And that's going to be 4, because 3 to the 4th equals 81. So this is asking 4 to what power equals 64? That's going to be the third power. 2 to what power equals 256? That's the eighth power. Now, 9 to what power equals 1? That's going to be 0. 1/3 to what power equals 1? Hey, look, that's also 0. Pi to what power equals 1? Also 0. Log base a of 1 is always going to be 0. Okay. So some special things. If there is no base specified, the base is 10. This is called the common logarithm. So the way you can think about this is there's an unwritten 10 here. So 10 squared is going to equal 100. When I write this, log base 10 of 1 over 1,000 equals -3. Well, I don't write the 10. Now, the logarithmic form of base e, which is a far more useful, highly used form, is called ln. The natural logarithm, logarithmus naturalis, some Latin thing, Greek thing like that. So normally I would write log base e of 20.09 is approximately 3, but we don't write log base e. Oops, sorry, I thought it was good. I had it to the side there. We write ln. So log base e of 2 is approximately 7 I'm sorry, I did this backwards. E to the 2 is approximately 7.39. There's no E written there. It's just so common, we don't need it. And so there you go. We have one more thing I want to go over here. A lot of calculators will not let you put in a base. So in order to compute this, they will only allow you to use base, log with no base or ln. You see it on your blue calculators. Pretty sure the iPhone calculator is the same way. So if you need to compute with a base, what you do is log base b over a or ln b over ln a. So to compute log base 3 of 73, you could type in log of 73 over log 3 or ln 73 over ln 3. No matter what, you'll get about the same number, or you'll get the same number, about 3.9. So here you would do log base 17 over log of 1/3, or log of 17 over, ln of 17 over ln of 1/3. And you'll get about -2.6. So the last one, you do log of 15 over log of 78, or ln of 15 over ln 78, and get you about 0.6. Okay, that should be it. Good luck.